Hi everybody. Day 2 in this sequence and series unit. So just making sure we're okay from yesterday. Got our do now here. Key thing, I see the word arithmetic. Now, seeing arithmetic, that's essential in knowing what formulas and what setup we're going with. Why is it arithmetic? Because in this situation we got plus 6, and that plus 6 is going to carry through the whole time. So that means our setup here, 618 equals T1 plus, we don't know n, minus 1 times our common difference of 6. 600 equals, in this situation, n minus 1 times 6. 100 equals n minus 1, n equals 101. All right, second problem, common ratio of a geometric. All right, so we got a multiply idea going on. If the first term is 6 and the fourth term is negative 3 over 4. So that means negative 3 over 4 equals 6 times r raised to the 4 minus 1. So if we divide by 6, we got times 1, 6. We got negative 1/8 equals r to the third. R, if we take the third root of both sides, is negative 1/2. Alright, so there's a little bit of review from yesterday. Now, what we're doing today is called arithmetic and geometric means. Alright, so an arithmetic mean between two numbers. So these are the numbers which form an arithmetic sequence. While geometric mean between two numbers, these are numbers which form a geometric sequence. With the two given numbers. So really, we're looking for the blanks. We're looking for the blanks in these situations. All right, so if we wanted to find one arithmetic mean between 4 and 16, basically our setup looks like this. 4 blank 16. All right, so in a basic idea, what are we really doing here? In a basic idea, we're finding an average. Now, this doesn't happen for every single one. This is only because we have, two terms and we're looking for what's between them. 4 plus 16 divided by 2 is 10. But really, the more complex way, I call it the real way of doing this, is to set up a formula. Right? This is a very formula-driven unit. So with our formula, what do we have? Well, we know in this situation that 16 is T3. We know that 4 is T1. So we could have 16 equals 4 times 3 minus 1 times our common difference. All right, divide by 4. So I got... All right, divide... Oh, I forgot something. Lose my mind. 4 plus. So the minus 4 gives me 12 equals 2D. D equals 6. And that's the key thing to figuring out 10 in the middle right there. Why? Because 4 plus 6 is 10. 10 plus 6 is 16. Right, taking this to a little bit of a different standpoint here. Let's imagine that we wanted 2. Right? Find 2 arithmetic means. Now it's means. Between 4 and 16. So here we got 4 blank blank 16. Right, so like last time, we still have T1. Now we got T4. So we got 16 equals 4 plus 4 minus 1 times D. 12 equals 3D. D equals 4. So we add 4 to get 8. We add 4 to get 12. We add 4 to get 16. Right, this is more along the lines of what we're doing. Right, we're going to make it more complicated. Make sure the one before where we add the two numbers divided by 2. That's very rarely ever going to happen. All right, so geometric mean between 4 and 16. And this is also called the geometric average, which is a little different than the arithmetic average. Okay, so Can we add them up, divide by 2? Absolutely not, because we have a thing being multiplied. And a lot of you are looking at this and you just know the answer of what has to go there. All right, but let's look at the way this works. All right, so similar idea. There's my T1, there's my T3. But we have a geometric setup. So we have 16 equals 4 times r to the 3 minus 1. 4 equals r squared. Key thing here now, r equals positive negative 2. Right? With arithmetic, you will only get one answer. Right? But with geometric, it's possible to have more than one geometric mean, which we just proved here. We got 2. So with that said, when r is 2, our setup is 4, 8, 16. When r is negative 2, our setup is 4, negative 8, 16. These are both the final answers. If you get 2 r's, you have to have 2 setups. If you get 3 r's, 3 setups, 4 r's, 4 setups, 5 r's, 5 setups, whatever it is, we have to put the answer through every single r value that we have. Now, again, with arithmetic, you're only going to get one common difference. So there's only going to be one answer. But with geometric, this can become a little more complicated with the fact that we have multiple answers. All right. Find 4 arithmetic means between 51 and 37. 51, 1, 2, 3, 4, 37. Jump to the formula. T1, 2, 3, 4, 5, T6. So I have 37 equals 51 plus 6 minus 1 times my common difference. Negative 14, 5d. D equals negative 14 over 5. Ugh. Now, depending on what your teacher wants, maybe you could just make that into a decimal. So in this situation, that's the same thing as negative 2.8. Alright, so if your teacher wants it in a decimal, that's fine. If teacher wants it in a fraction, that's fine too. For the purpose of right now, we're home, so we can use our calculator, so it wouldn't matter which way we did it. Alright, so if we work with the decimal here, we got 48.2, 45.4, 42.6, 39.8, which gets us to 37. So there are my 4 arithmetic means in this situation. Alright, 3. Right, 3 geometric means between 6 and 96. Allowing the common ratio to be a complex number. So you see that complex number, you know what that's telling me? Usually there's going to be some form of rads or i's involved in this. Right? So it's saying it can be as complicated as possible. Right, so will there be an I here is the question. So 96 equals 6 times r. How many terms I got? 5. 5 minus 1. 16 equals r to the 4th. Now here's what a lot of people do. People make the error, they raise both sides to the 1/4 power, and they say that r equals positive negative 2. That's not wrong. Okay? Not wrong. That makes sense. But when you see the saying where it says complex numbers, you have to make sure you get all 4 roots. We only got 2 here, right? We know from previous units that if the exponent's 4, there are 4 roots. We only got 2 right now. All right, so what can we do in this situation to make sure we get all 4? I'm a fan of factoring. All right, so if I went with a factoring method here, r to the 4th minus 16 equals 0. R squared plus 4, r squared minus 4. I don't know why I just wrote an F. Not an F. R squared plus 4, r minus 2, r plus 2 equals 0 equals 0. From this here, we get r equals positive negative 2 and r equals positive negative 2i. Alright, so we got all 4 roots. So know what that means? We have to have a setup when r is 2, when r is negative 2, when r is 2i, when r is negative 2i. We have to have every single setup to show all the different setups of geometric means that this problem could have due to having 4 different r values. So we got r is 2, 12, 24, 48. When r is negative 2, negative 12, 24, negative 48. Right, when we got 2i, right, so we got 12i, then we have 24i squared, which becomes negative 24. Then we have negative 48i, which will get us to 96. If we have negative 2i, we have negative 12i, which gives me in this case negative 24, because I'd have, again, 24i squared, 48i, and 96. So in the end, all 4 of these are legit answers to this problem. And we got to show all 4 of them. They're all important in their own way. Okay, so moving along to the last 2 problems here. All right, we got a lying problem. Right? I call these a lying problems. So I see right now, I need T1, I need T40, but to get those, you have to find our common difference. But our common difference formula, Tn equals T1 plus n minus 1 times d. If I plug in what I have now, I'd have something like 7 equals T1 plus 10 minus 1d. Well, I have 2 variables there, and that's just not helping me. So I like to think about this problem as a lying problem. So what I do is, I'm going to pretend for the moment that this is now T1. Now, if I subtracted 9 from 10 to get 1, if I subtract 9 from 19, T10 is now 10. So for the moment, I'm just pretending. So I can make this 10 equals 7 plus 10 minus 1 times the common difference. This is based off my pretend idea. 3 equals 9d, d equals 1/3. Got my common difference. All right, I'm on my way now. So now going back to my original numbers, right, pretending this is gone now and this is gone now, I'm going back to T10 is 7. 7 equals T1 plus 10 minus 1 times 1/3. 7 equals T1 plus 9 times 1/3, which is 3. T1 is 4. So I cheated at first and made up a lie to solve for the common difference. Then I went back to my original numbers to solve for T1. Now I'm able to solve for the final answer of T40. T40 equals 4 plus 40 minus 1 times 1/3. T40 equals 40 plus 39 times 1/3 is 13. T40 equals 17, and that's my final answer. All right, many step problem here. Finding the common difference, finding the T1, finding the T40. I go step by step by step by step in all these situations. All right. That problem wasn't even a geometric mean or an arithmetic mean problem. This is just thrown in there, a little review problem. All right, 2 means between 1/9 and -3. All right, complex. So it's saying complex, so it wants every single option. So I got -3 equals 1/9 times r to the 4 minus 1. So I got -27 equals r to the 3rd. R to the 3rd plus 27 equals 0. Cube rule, r plus 3, r squared minus 3r plus 9. Okay, so the nice clean root that I get here is r equals -3. That's my first R value. That's at the dream R value. The other one, what am I going with here? Well, if I go quadratic formula, x equals 3 plus minus negative 3 squared is 9 minus 4 times a times c all over 2. X equals 3 plus minus, what number I got? I got rad negative 27 over 2. So what does this simplify down to? X equals 3 plus minus, take out the negative 9, 3i rad 3 over 2. And I kid you not, in this situation, those R values legit do work. Alright, so if I'm using negative 3, everyone's favorite setup here, I got R equals negative 3. I got negative 1/3, 1, and negative 3. Alright, again, complicated. I'm just going to write the positive setup. Alright, so with the I that's positive. So I got 1/9 times 3 plus 3i. I gotta show it over here. 1/9 times 3 plus 3i rad 3 over 2. Divide by 3. 1, 1. So that gives me 1 plus I rad 3 over 6. So now if I do 1 plus I rad 3 over 6 times 3 plus 3i rad 3 over 2. That's going to get even uglier at the moment. So I'm foiling here. So I got 3 plus 3i rad 3 plus 3i rad 3 plus 3i squared rad 9, 3 plus 6i rad 3 minus 9, negative 6 plus 6i rad 3 over 12, which gives me in this situation, divided all by 6, negative 1 plus I rad 3 over 2. Negative 1 plus I rad 3 over 2. All right, lots of work going into that. Okay. And then again, to show you the last step here, can we finish this off and actually get the number we want? Well, if we have negative I plus I rad 3 over 2 times 3 plus 3i rad 3 over 2, we'd have a FOIL up top. We got negative 3 minus 3i rad 3 plus 3i rad 3. Then we'd have plus 3i squared rad 9. Negative 3, cancel, minus 9. Right, negative 3 times minus 9 over 4. Negative 12 over 4 equals negative 3. There it is. It does work. Alright, the last one works too with the negative. I'm not going to go through that whole process there. We got 1/9. Then we'd have 1 minus I rad 3 over 2, over 6. Followed by negative 1 minus I rad 3 over 2. Then negative 3. So it does work. I'm just not going to go through the whole process showing the foiling and everything again. Alright, key thing. Geometric mean, finding the spaces between. Arithmetic mean, again, finding the spaces between. Arithmetic mean is only one option of the common difference. With the geometric mean, there's many options. Right? So the fact in this problem, we got 3 R's. The problem 4 up there, we got 4 R's. They could be I's, they could be rads, it could be whatever they're going to be. You know, whatever it is, you just got to work your way through it and find those blank spaces.